Section 3.3, Example 7. A jar contains 5 red, 7 blue, and 5 purple candies. If the total number of candies is 20, determine the probability that a handful of 4 candies contains exactly one of each color. So first of all, if we add up the candies we have, 5 plus the 7 plus the 5, we have 17. We are told, however, there are 20 candies in total. Section 3.3, Example 7. A jar contains 5 red, 7 blue, and 5 purple candies. If the total number of candies is 20, determine the probability that a handful of 4 candies contains exactly one of each color. First of all, if we add up the candies we have, 5 plus 7 plus 5, that is only accounting for 17 candies. We are told there are 20 candies, so 20 subtract 17, that means there must be 3 other candies that are not red, blue, or purple. We are looking for the probability that a handful of 4 candies contain exactly one of each color. First of all, we're going to look at our total number of ways. If we have 20 candies and I want to select 4 of them, the order in which we select those 4 does not matter. So this is a combination. Our total ways are 20C4. And that gives us 4,845. Looking at our favorable outcomes, we want exactly one of each color. So we are looking for 1 red and 1 blue and 1 purple and 1 other. The number of ways to choose 1 red is 5C1. And so we multiply. There are 7 blue, so 7C1. And multiply again. To pick 1 purple candy, it is 5C1. And of the other 3 remaining candies, we need 1 other candy to make up our 4 candies. This gives us 5 times 7 times 5 times 3. There are 525 favorable outcomes. So to find our probability, we are going to take our favorable outcomes and divide by the total. 525 divided by 4,845, or written as a percentage, that gives us 10.8%.